Today we'll discuss. Hi everyone. Today we'll discuss generalized mean value theorem. Generalized mean value theorem. So, what is the statement? If three functions f, g, and h are defined on the closed interval ab are in such a way that they are continuous in the closed interval ab, derivable in the open interval ab, and there exists a real number c such that determinant of f dash c, g dash c, h dash c, f of a, g of a, h of a, f of b, g of b, h of b equal to 0. We have to prove this and some deductions. We'll go one by one. So proof what we are doing, we are proving it. So now consider the function phi of x on the closed interval ab defined by phi of x. We are defining in such a way that determinant f of x, g of x, h of x, f of a, g of a, h of a, f of b, g of b, h of h of a, h of b. Okay. Now phi of x this. Then suppose phi of x is the sum of, if we expand the determinant, suppose a of f of x plus b of g of x plus c of h of x, where a, b, c are constants. Where a, b, c are constant. Since f of x, g of x, h of x is continuous in the closed interval ab, and phi of x is the linear combination of f of x, g of x, h of x, so that implies phi of x is continuous in the closed interval ab. Second one, phi of x is derivable in the open interval AB, and also phi of A equal to phi of B, because two rows become identical when we take x equal to A and x equal to B. Two rows become identical. So that means what? Phi of x is continuous, phi of x is derivable, phi of A equal to phi of B. This is possible only when two rows become identical when we take x equal to A, x equal to B. That means what? Phi of x satisfies all the three conditions of Rolle's theorem. Therefore, there exists C belongs to open interval AB such that phi dash C equal to 0. So that means phi dash C equal to 0. That means phi dash x equal to A f dash x plus B g dash x plus C h dash x. So this implies f dash x, g dash x, h dash x, f of A, g of A, h of A, f of B, g of B, h of B. Since phi of x satisfy all the three conditions of Rolle's theorem, there exists C belongs to open interval AB such that phi dash C equal to 0. That means f dash x f of a, f of b, g dash x, g of a, g of b, h dash x, h of a, h of b should be equal to 0. Hence, we prove the theorem and we prove the generalization. Now, we will consider one particular case. Suppose case 1. Case 1, if you consider, if h is a constant function. Suppose h is a constant function. If we suppose h is a constant function, let h equal to k. That means h of a equal to h of b equal to k, and h dash c should be equal to 0. So our our 1 reduces to what it will reduce? It will reduce to you see, phi dash c equal to 0 means this equal to 0. 1 minute. So this reduces to f dash c, f of a, f of b, g dash c, g of a, g of b. H dash c equal to 0 because constant. This is k, this is k. Determinant equal to 0. Now expanding the determinant. Expanding by C3. First column, second column, third column. Expanding by C3. So first will go off. The second will be there. Second, if we go this will be f dash c into k minus g dash c into f of b. G dash c into f of b. This is 1 plus last k. If you take over this, take f dash c into g of a minus g dash c into f of a. Okay, equal to 0. Now this one, if I so k is common, so k is common. So this means yes, k we have taken common. K is common. K will not come here. So this one means f dash c into g of b, not g of b, sir. This is g of b. K of yes, okay. So now k of f dash c, if you take common, this is g of a minus g of b. G of b. Next, then if we take k common, this will be minus k common. If we take common, oh, minus, what shall we do? If I take minus k g dash c, if I take common, minus take g at this is f of f of a minus f of b equal to 0, equal to 0. Now k is common, k cannot be equal to 0, so this part equal to 0. So f dash c into g of a minus g of b equal to g dash c. Why I'm writing this? So g dash c into f of a minus f of b. So now if I write f dash c by g dash c, this if I write g of b, f of b minus f of a minus comma g of b minus g of a. What is showing? What does it mean? F dash c by g dash c equal to f of b minus f of a. Which is Cauchy mean value theorem. Which is Cauchy's mean value theorem. Now case 2. Suppose case 1 we have taken, we got. Now case 2 if you take, suppose g of x equal to x we have taken and h of x equal to constant function. So g dash x equal to 1, g of a is a, g of b is b, h of a is k, h of b is k, h dash x is 0, h dash c is also 0. Now this is first deduction, case 1 we have. Case 2 if you take g of x equal to x and h of x equal to constant. So constant h of a is k, h of b is also k. H dash x equal to 0, h dash c equal to 0. Now put in the bracket. What is the bracket? F dash c, f of a, f of b. What is g dash c? G dash c is 1, g of a is a, g of b is b. What is h dash c? 0, constant, should be equal to 0. Now expanding by C3. So second one minus, so this will go off. What you are getting? F dash c into b, f dash c into b minus f of b, minus f of b. One thing, this if we take f dash c into this, 1 is there, no? Yes, f of. This is minus, this is plus k. Now leaving this and this, so a into f dash c minus f of a should be equal to 0. Should be equal to 0. Should be equal to 0. Now f dash c if you take in common f dash c if you take common f dash c, so this is a minus b, minus into minus plus f of b minus f of a equal to 0. So this is a minus b, I can write, and k is there. K cannot be equal to 0. So therefore this part is equal. You see these 0 divisors. A dot B equal, you see, for example, phi x equal to 0. Phi cannot be equal to 0. We are taking x equal to 0. 0 divisors. Linear algebra. I will make the video on linear algebra. I'll discuss there. So this is, now if you take there, so this one, if we go to that site, f dash c equal to f of b minus f of a minus b is same as b minus a. If you write this is in the straight which is, what is this? Which is LaGrange's mean value theorem. So from the general equation, we have reduced, first we prove taking three theorems. You see, what we have done, let me say, there are three functions. What are the three functions? F of x, g of x, h of x are given functions. And he said it is continuous, it is derivable. Then there exists C belongs to open interval AB such that he gave the determinant equal to 0. We have to prove that. To prove that, we have taken another function phi of x equal to determinant phi of x equal to a f of x plus b g of x plus h f of x, where a, b, c are the constant. Now, f of x, g of x, h of x are continuous, it is given. So, right hand side is continuous, left hand side is also continuous. Then, they are derivable. Derivable is given, so sum of derivable function is also derivable. That means right hand side is derivable, left hand side is also derivable. Then what did? Then there exists C belongs to open interval AB such that phi dash C equal to 0. We took the determinant and we proved that phi dash C equal. Then we have taken case 1. What the case 1? We have taken h as a constant. Put the value of constant function, expanded, we got Cauchy mean value theorem. Again we consider the case 2, we have taken g of x equal to x, we have taken h of x is constant function. Then we got the Lagrange's mean value theorem. We have deducted the Lagrange's mean value theorem. That's it. Very simple. It is a theoretical math. So it appears to be boring, but I try to make it as simple as possible as I can. Thanks for watching. Please subscribe my channel for more upcoming videos. Whatever videos you want, I'll make on the math. Thank you.